Hi, my name is Aaron Enger, and this is my results of the UAV drone search project. I used a modified complete coverage algorithm, so instead of just blindly going up and down, it actually targets high priority zones first, puts bounding boxes around them, and does a lawnmower type search on those areas first before going back to the rest of the area. And it finds those based off of the mean and standard deviation of all the probabilities. Here's the CDL, so as we see over time, it targets the higher priority areas first and then tapers off. And likewise, we see that with the second graph as well. Here's the efficiency graph. So we see over time, both heat maps become more efficient. And slightly, the first one is a little bit more efficient, probably because when it's doing the rest of the search, it searches all these diagonal areas first rather than some of the zero probabilities out here. So is this an AI search algorithm? I would say so. There's an initial state with the drone at 0, 0. There is actions, which the drone can move to all the different locations on the map. There's a transition model, which is the drone moving to new locations from previous ones. The goal test, which is complete coverage of the entire space. And the path cost is one step takes 1 unit of time. The category, I would say this is a informed search because it has information about the higher priority areas where it goes to first, and then it kind of does a blind search for the rest of the space. And as I said previously, it is modified from the paper. It does target higher priority bounding boxes first, and then it focuses on the rest of the areas. Some interesting surprises: when the drone got stuck previously when I was first implementing it, what I had it do instead is a breadth first search to find the nearest area it had not searched, and then starts a lawnmower search from there. And then for improvements, I would say that I would implement, instead of just bounding boxes, have any shape boxes around any high priority zones would help. Plus, perhaps implementing a hill climbing algorithm would help as well. Anyway, thank you for listening, and that is the presentation.